Mercury, the smallest planet in our solar system, is a world of extremes and mysteries. It holds the distinction of being the closest planet to the Sun, a position that subjects it to intense solar radiation and gravitational forces. Its orbit is a mere 36 million miles from the Sun, a fraction of Earth's distance. This proximity means that Mercury experiences some of the most dramatic temperature variations in the solar system. Due to its proximity, Mercury completes an orbit around the Sun in just 88 Earth days. This rapid journey has earned it the nickname the Swift Planet. This swift orbit is not just a fascinating fact, it also has significant implications for the planet's surface and environment. Despite its small size, Mercury is a dense world. It is primarily composed of iron and nickel, materials typically found in the cores of planets. This dense composition suggests a fascinating history of planetary formation. Mercury's high density indicates that it has a large metallic core, which makes up about 85% of the planet's radius. This dense composition suggests a fascinating history of planetary formation. Mercury likely experienced significant impacts in its early life, stripping away its outer layers and leaving behind a metal-rich core. These impacts not only shaped its surface, but also influenced its geological and thermal evolution. The planet's surface is marked by numerous craters, a testament to its violent past. Mercury is a terrestrial planet, meaning it is a rocky world like Earth, Venus and Mars. However, unlike its terrestrial counterparts, Mercury lacks a substantial atmosphere. This lack of atmospheric insulation contributes to its extreme temperature swings, making it a planet of stark contrasts. During the day, temperatures can soar to 800 degrees Fahrenheit, while at night they can plummet to minus 290 degrees Fahrenheit. This lack of atmospheric insulation contributes to its extreme temperature swings, making it a planet of stark contrasts. From scorching hot days to frigidly cold nights, Mercury presents a challenging environment for exploration. From scorching hot days to frigidly cold nights, Mercury presents a challenging environment for exploration. These temperature extremes pose significant challenges for any spacecraft or instruments sent to study the planet. Despite the challenges, Mercury holds valuable clues to the formation and evolution of our solar system. Its unique characteristics offer a glimpse into the processes that shaped the inner planets billions of years ago. Its unique characteristics offer a glimpse into the processes that shaped the inner planets billions of years ago. By studying Mercury, scientists hope to understand more about the early solar system and the conditions that led to the formation of Earth and its neighbours. As we continue to explore Mercury, we unlock secrets about not only this enigmatic world, but also our own planetary neighbourhood. Each mission to Mercury brings us closer to understanding the complex dynamics of our solar system and the history of its formation. Mercury's proximity to the Sun dictates its extreme temperature fluctuations. Being the closest planet to the Sun, Mercury experiences some of the most severe temperature changes in our solar system. During its long days, the surface bakes under the intense solar radiation, reaching temperatures as high as 800 degrees Fahrenheit. This intense heat is a result of Mercury's lack of a significant atmosphere to deflect or absorb the Sun's rays. This extreme heat is enough to melt lead, illustrating just how scorching the surface can become. The landscape under such conditions is harsh and uninhabitable, with rocks and dust absorbing and radiating the Sun's energy. However, as Mercury rotates slowly on its axis, its nights are equally extreme. The planet takes about 59 Earth days to complete one rotation, leading to prolonged periods of daylight and darkness. Without a substantial atmosphere to trap heat, the surface temperature plummets to a frigid minus 290 degrees Fahrenheit during the night. This drastic drop is due to the rapid loss of heat into the vacuum of space. This dramatic temperature swing of over 1000 degrees Fahrenheit makes Mercury the planet with the greatest temperature variation in our solar system. The lack of atmospheric insulation means that the planet's surface is directly exposed to the harshness of space. These extreme temperatures are a direct result of Mercury's slow rotation and lack of atmosphere. The thin exosphere, composed mainly of oxygen, sodium, hydrogen, helium and potassium, is not sufficient to moderate the temperatures. A day on Mercury, measured as the time it takes for the Sun to return to the same position in the sky, lasts 176 Earth days. This extended day-night cycle means that one side of the planet is exposed to the Sun's heat for an extended period, while the other side remains in darkness. This extended day-night cycle allows the surface to absorb immense heat during the day and radiate it back into space during the long night. The lack of an atmosphere means that there is no medium to retain the heat, leading to rapid cooling once the sun sets. The absence of a substantial atmosphere to regulate temperature exacerbates these extremes. The surface cools quickly, leading to the severe cold experienced during Mercury's night. Unlike Earth, where the atmosphere acts as a blanket, trapping heat and moderating temperatures, Mercury has only a thin exosphere. Earth's atmosphere, rich in nitrogen and oxygen, helps to distribute heat around the planet, preventing such extreme temperature fluctuations. This exosphere, composed of particles blasted from the surface by solar wind, provides little insulation against the sun's heat or the coldness of space. The solar wind constantly strips away particles from Mercury's surface, maintaining the thinness of the exosphere and contributing to the planet's inability to retain heat. The interaction between the solar wind and Mercury's surface is a continuous process, further emphasizing the planet's vulnerability to temperature extremes. The rocky terrain, devoid of any significant atmosphere, is a testament to the harsh conditions that define Mercury's environment. In summary, Mercury's extreme temperature fluctuations are a result of its proximity to the Sun, slow rotation, and lack of a substantial atmosphere. These factors combine to create a planet of stark contrasts, where the environment is as unforgiving as it is fascinating. Mercury's surface is a testament to its tumultuous past, a history written in the language of craters and valleys. Billions of years of relentless bombardment by asteroids, comets and meteoroids have left their indelible mark on this small, rocky planet. These impacts have sculpted Mercury's surface, creating a landscape filled with craters, valleys and vast impact basins that tell the story of its violent history. One of the most prominent and awe-inspiring features on Mercury is the Caloris Basin, a colossal impact site that stands as a testament to the immense forces that have shaped the planet. This enormous impact basin spans approximately 960 miles in diameter, making it one of the largest impact features in the entire solar system. The sheer size and scale of the Caloris Basin are a reminder of the powerful events that have occurred in our solar neighborhood. The impact that formed the Caloris Basin was so powerful that it sent shock waves reverberating through the planet. These shock waves traveled across Mercury, creating a region of chaotic terrain on the opposite side of the planet, a stark reminder of the cataclysmic event. Beyond the Caloris Basin, Mercury's surface is a mosaic of craters of various sizes, each telling a part of the planet's story. These craters range from small, bowl-shaped depressions, which are relatively simple in structure, to larger, more complex craters that feature central peaks and terraced rims. These larger craters are formed by more significant impacts and reveal the dynamic processes at play during their formation. The high density of craters on Mercury's surface indicates that it is ancient, dating back to the early solar system when impacts were far more frequent. This ancient surface provides a window into the past, offering clues about the conditions and events that shaped the early solar system. In addition to its craters, Mercury also exhibits long, winding valleys known as rupees. These features add another layer of complexity to the planet's surface. These rupes are believed to have formed as the planet cooled and contracted over time. As Mercury's interior cooled, it caused the crust to fracture and wrinkle, creating these distinctive valleys. The discovery of these features has provided compelling evidence that Mercury, despite its small size and proximity to the Sun, has experienced significant geological activity throughout its history. This activity has shaped its surface in ways that continue to intrigue and fascinate scientists. As we continue to study Mercury, each new discovery adds to our understanding of this enigmatic planet. Its craters, valleys, and the majestic Caloris Basin are not just features on a map. They are chapters in the story of our solar system, each one offering insights into the processes that have shaped not only Mercury, but also the other rocky planets. Mercury's surface, with its rich tapestry of geological features, serves as a natural laboratory for scientists. By studying these features, we can learn more about the history and evolution of the inner planets, including our own Earth. The story of Mercury is far from complete, and as we continue to explore, we uncover more of the secrets held by this small but fascinating world. Our understanding of Mercury has been significantly enhanced by two groundbreaking missions, Mariner 10 and Messenger. These robotic explorers ventured close to the Sun, braving extreme temperatures and radiation to unravel the secrets of this enigmatic world. Mariner 10, launched in 1973, was the first spacecraft to visit Mercury. It performed 3 flybys of the planet, capturing the first close-up images of its surface. Mariner 10's observations revealed Mercury's heavily cratered terrain, its tenuous atmosphere, and the presence of a global magnetic field. These discoveries revolutionized our view of this previously mysterious planet. Following in Mariner 10's footsteps, the Messenger spacecraft, launched in 2004, embarked on a more extensive mission to Mercury. Messenger orbited Mercury for over 4 years, mapping its surface in unprecedented detail and collecting a wealth of data about its composition, geology, and magnetic field. Messenger's observations confirmed the presence of water ice in permanently shadowed craters at Mercury's poles, a surprising discovery given the planet's proximity to the Sun.